Okay. Welcome. Good morning. كيف حالكم? All right. So, welcome to our very first time that we're doing the data science workshop series in this room. I'm glad that you didn't get lost because it's not well known yet, but as you can see, it's very nice. So, we're here because we want to know about Shell, and this is the starting path for data science. There are several workshops of this that are actually prerequisites to the next three workshops that are the machine learning workshops. Okay? Thank you for being here. So, let's start. Who am I? Well, I am Dr. Didier Barradas Bautista. I am part of the KVL, the KAUST Visualization Core Lab. In the KAUST Visualization Core Lab, we have several experts. I'm one of them, apparently, and I'm the data scientist of the team, alongside with Dr. Abdul Raful Halimi. But also we have visualization scientists that can do wonders. Like, for example, Ronald is the VR specialist. Tom and James, they are wizards of visualization, large data using the supercomputer. Now, if you didn't know about us, well, now I'm going to present you. We have an actual wiki that you can check. You probably saw it when you came to the links, the web pages that you were actually signing in, and on there you can check it out every time that you want. We have several things over there, like the training list that we are delivering every year, and also some tips for you for IBEX or for data science. Also, there is our contacts over there. Okay, so let's start. What is Shell? Well, as you can see it right now, and we're living in a wonderful world where everybody has access to a machine, you know that that machine, now that you have in front, it passed through several generations and iterations of development. And how do you talk to your machine right now is very advanced compared to what people had in the 70s or in the 60s. So one of the first things that they developed was a common language interpreter. And one of those is called Shell. Why it's called Shell? Because literally this is a shell between you, talking normal language people, and the computer, which is binary. This is why it's called Shell. Literally a shell between you and the machine. So it's an operating system, and it lets you do different tasks very quickly, a lot of tasks indeed. And it's been around since the 70s, as you can see. It was redesigned in the 80s, almost 90s, and many people refer it as Bash, so born again shell. One of your colleagues right now was asking me, what's the difference between shell and Bash? Is how old are you? Why? Because if you were born in the 70s, you know this as shell, and then if you're in the 90s, you think about this as Bash, but they're basically the same thing. So when people refer to a shell script or a Bash script, the same thing. So don't be scared about the terminology. Okay, why should you learn this thing? The one that I like is because I look like a hacker to everybody that is asking me, like, what are you doing? Then they see the black thing and it's like, whoa, wizard things. And it's pretty much cool. I am not going to lie. But true is that it's very powerful. It makes you work quick. If you master it, it will make you work super fast. And it will allow you to handle a lot of files at the same time. Have you ever tried to do like several changes of the same word over in one document? You can do it with Shell if you know how. So also, because you're here at KAUST, and people that is looking at the stream probably will wonder, well, why in the world do I want to do this? If you want to work in data science, you will end up trying to access a supercomputer, namely an Amazon web server, or in our case, we have two clusters, Shaheen and IBEX. And you need to know this to actually do work in those things. Because if you don't know Shell, you can't do a squat. So this is why you want to do this in the first place, because you're here. But in the big scheme of things, it will help you just to be faster in your work of day in and day out. depending on how many files you have to handle and the type of files you have to handle. All right. So this material is based on something that is called the carpentries. I am certified by this, let's say, organization. It's a nonprofit that it's dedicated to give students that want to learn how to code a lot of materials, well explained. This is what we're going to use. They have so many other things that I cannot tell you about right now. For example, they have an HPC, high performance computing course that you can actually read, check it out. Python, R, Julia, even Conda, you will see it there. They have a lot of materials, different language too. They have another tool that is called Glossario, in which all the terminology that you are wondering, what is this thing meaning, is probably on your language. There is Arabic, there is Czech, there is Portuguese, there is Spanish. They have all these translations, okay? You can find it. It's just a matter of Google it, literally. Okay. So we're going through these 5 parts. Hopefully you will not die in any of these parts of exhaustion, because it could be very overwhelming. But we will try to go over, and we will try to work together to go all the way. Okay? So, one thing, we can start with the setup. If you read the web page, you know that there was a setup over there that you can install on your computers. That would be my advice, like do it on your computer. But if you didn't, and because you're here at KAUST, and you're very lucky to be here at KAUST, we have a tool for you that you don't have to do anything in your computer. You just have to click. The only requirement was to have a GitHub account and put it on one of the lists. This is why I'm going to ask you, was the web page actually clear for that? Because this is my first time I'm trying with that web page specifically to give directions. So raise your hand if you actually saw the web page. Okay. Did you find the setup? Was it clear? Sort of? Okay, good. So Windows users, I don't know why you do that to yourself, but you have many different tools here. The Mac users have already a terminal inside, and you can use that if you don't want to use a resource. And Linux users, you already have also a terminal, because Shell is basically a son of Linux. Okay? So this is the web page that I was talking about, okay? So in one side, in the actual left side, you have the workshop materials, which are these slides, and you have something that is called Etherpad that you put over there, okay? This Etherpad over here is going to be our collaborative document. You will see it in a bit, and we will all check it out. Why do I want this? Because this will be notes for you, and you have this service also at KAUST. You can create an Etherpad and share it with all your colleagues during classes or during a project or whatever. It's very easy to set up. Then you have here the lesson material that we will be checking out. That's the link, the direct link for all the setup, all the material that we're going to work. And you can go over it all the time, because it's for there, it's for you and the users, everybody. Then all the KAUSTians, you have access to something that's called ClassHub. And I will be using that thing in order to get this done. You also have a Jupyter Hub, but I did not put any file over there, because each Jupyter Hub is for each of you. So I cannot access anybody else's Jupyter Hub, but you can use it. And it's connected to DataWaha and so on and so forth. Very useful tool. Okay. So for the ClassHub, go ahead, try to get it up and running. You will go to some web page that doesn't look like that in the moment. But if you scroll all the way down, you will see these 3 buttons that say GitHub repository, begin your course, and Jupyter Hub. Click begin course, sign in with GitHub, and then you will have something that goes like this for a while. It will say binder, and it will start spinning the machine. This is a virtual machine. Technically speaking, it's a container that is going to deploy something, but let's forget about the mumbo jumbo. it's just going to spin a new machine for you. So please, right now, do this. Go to the web page, begin course. It doesn't look like this advertising here of data science, sorry, but if you go all the way down, you will find this button. Okay? I'll give you a couple of minutes. Yes. You don't have access. You're not in KAUST. Okay. So for those of you that are not in KAUST, I have another solution. It's not the greatest solution. But if you go, for example, there is another thing that I put. There is a binder. I will show you the web page. Let's go back. One more. So over here on how to prepare, there is something that is called public binder. Click there. In public binder, click there, okay? That one will get you all the way to a GitHub repository that I have. Then you go all the way down, and in all the way down, you will see badges. You click in launch, and then it will spin a binder, okay? That's also for people in YouTube that are looking at this. They can do that. Whatever they can do, like this is why I like local setup was better. The problem is this is a small resource, right? It's not like the class hub. So you can get this done. It will be the same machine as people that are using the class hub. But that's the trigger. You go to the GitHub page, you go all the way down where badges is, you click binder, launch binder, it will spin that machine for you that you are outside the KAUST web protection. Okay? I saw other hands raised. Could you deploy the class hub? You can't. Okay. But you have a Mac. Okay. You can use the terminal. If you have a Mac and you cannot access this, use the terminal. Okay? Yes. Do you have a GitHub account? Did you give yourself an update on the link at the bottom? If you go here, one more. Yes. You see, there is, after you create your GitHub account, get access here. Okay? So you have to put your GitHub account there. You did that, and you still don't have any access. Okay, in that sense, you can use the public binder too. It will spin a small machine just like your colleague over here. Go to the public binder that is over here, this link here. And then you go all the way to the bottom of the page, and in badges, you have launch binder. Click launch binder, and it will spin a machine for you. Okay? I have a remote, or let's say, this was why I wanted pretty much everybody to have a local setup, because now you can work on your computers without this hassle, but this is something that you can do later. Don't worry about it. So far, we have the public binder, we have the class hub. Hopefully, everybody can spin a machine for you, or everybody has a machine spawn for you, you said. Okay, so while we are doing that and waiting for that, you will get something that looks like this. It will deploy something that is called a Jupyter notebook or a Jupyter lab. So the layout, as you see, and you will find this everywhere where you go with data science on the title, even the machine learning workshop that we're going to give, you're going to use this, okay? So you have basically from one side all your files, and in here you have several options. This one will deploy Python, this one will deploy Julia as a notebook that you will use for Python and for machine learning. But right now, I want you to click on this one when you see it, okay? Once the machine is spawned and this appears, you go over here and you click in terminal, all right? Okay. So far, I just want to know how many of you have spawned a machine with the class hub or have a terminal. You have a terminal? Terminal over there? Yes? Yes, I know you do. Over there? All good? Okay. So everybody has spawned something like this. Pretty much? Okay. So about the collaborative nodes, I want you to use the Etherpad. Why? Because this is something that we can use to communicate. I will be able to communicate live with people that is looking at this on the YouTube channel. And also, what is going to be very useful for you is just start one of these amazing assistants. You have a Google account or something like that. Here at KAUST, you have access to Copilot. So let's use that, okay? You can spawn a new, I don't know, Gemini assistant, and it will help you when you have some kind of doubt. Like, how do I write this the correct way? These guys are for that, as a matter of fact, to help you to be more productive and to correct you in some sense when you don't know where to go, okay? Use Gemini, Chat, GPT, or Copilot. It's the same, okay? And I advise this because usually you get lost and it's like, okay, so should I say something or not? These guys have the answer, probably. Okay. In this case, if you already have a terminal, do this. I want you to write echo, double quotes, hello world. Tell me what happened. Okay? Who's brave enough to tell me what happens when you do hello world? You print hello world in your terminal, exactly. All right. Now do the second one. Echo, double quotes, echo hello world, then greater than hello.sh. The second line. Try it. Okay? Does it print anything in your terminal? Nothing, exactly. It prints nothing. Now, after you do the second one, do the third one. Do bash hello.sh. Okay? After you do the third one, it prints it into your terminal, right? Okay? Excellent. You have done honor the hello world tradition in the computer science. This is the first program that you have written, as a matter of fact. You have just wrote a program called hello.sh. .sh is the termination, just like .doc for Microsoft Word. This is for shell.sh, okay? Just like, for example, for Python, the termination is .py or py, and so on and so forth. So this is just to separate, let's say, this to organize all the types of files that you will actually work with. Oops, okay. So congratulations, you did your first program. I know that at this point you know everything about Shell. You're free to go. Yeah, right. Okay, so let's do the following. So I have been talking too much about my website. Well, the website should be in mind. So if you go to the Etherpad here, you will go into this thing that I have over here. I call myself Master Roshi because I am old, I am bold, and I will make you Super Saiyans when you end up this course, okay? So you can write whatever you want here. You can write questions or you can take notes. It's okay. So go ahead, get into this thing, say hello in the chat. That's okay. If you're shy, you don't have to put your name. You see, there are already 5 people that says unnamed. If you have a very burning question that you don't know how to ask and you are shy, don't put your name there. Just throw the question, okay? It's okay to be unnamed here. It's not Twitter. So, and I know you're not bots, so you can write actual normal human things, I hope. So, yeah. And, okay. So if you're here in the Etherpad, super, super nice. Thank you, Abel, Ahmed, Raghu. Unnamed 1, also hello. Unnamed 2, also hello. Okay. Tiziana has already said something over there. Tiziana is my assistant for this workshop. So if you can ping her, it will be faster. If not, if I catch your question over here, that's okay. Okay, we will take this out. I can have it here. Well, okay. So, if you remember, I told them that we have the lesson here. Okay, these are the workshop's material. It's for you. It's always there. This is not private. This is from the carpentry. It will tell you how to set up your machine after your workshop. After this workshop, if you have Windows, you can go over here, check this out. And I know the hardest part of this is to read. So you just have to read the stuff, and it will tell you how to do all the setup for your machine. Okay? In this case, for example, it says like Mac already has a terminal. You don't need to do anything else. That's fine, and so on and so forth. You can install your software, and you can download the files. Okay? Now, for those of you that didn't have the fortune to spawn a class hub, you can download the material from here. Okay? On the other hand, if you enter the class hub or you spawned a machine already from here, if you spawn a machine from the KBL binder, you will find these files over here. Am I right? Is everybody on that side? Okay. Can you see these files? Like getdata.sh. Okay? If you all have that, we're good. If not, raise your hand. We wait for you. Going once. Going twice. Going thrice. Okay. I will assume that everybody kind of knows about it. Can you download the material? Okay. You have it? Excellent. Okay. Now you have a terminal. Okay? The terminal is this big black, well, on Mac, it will be a big black block, but this is white. Okay, so let's start downloading the material. No, wait. Before everything, I should tell you, let's actually start by knowing how or where I am. This is the beautiful part about Shell. It will actually solve some personal crisis like, I don't know who I am. Who am I? Okay, it tells me your name here is Jovian. Okay, that's excellent. So personal crisis, identity crisis averted. Now, if you want to know where you are, you can do print worker directory. Okay, and it's telling me, hey, you are here, /home/Jovian. So these slashes are actually something that is part of the structure of the thing. And if I recall correctly, is over here. So if I blow up this, you see this image? This is how is this. Wait a minute, technical problems. Okay. So in Linux, this is the structure of the system. You have something called root, which is this slash. This is the toughest of the toughest part of your machine. This is the most literally root part where everything spawns. And then you have different folders like bin, data, users, temp. This is a normal thing to have even in Windows, but in Windows, the slash is in the other side. It's not like tilted on the left, it's tilted on the right. Okay? So if you want to navigate this to go, let's say, to Imhotep, Larry, or Nell folders, you have to know how to navigate, but you have to also know where you are. This is why print working directory is telling me you are in slash, then home, then you are in your user. This is basically it. This is your map. This is where you are. This is your path, or what people in computer science like to call it, the absolute path. All right? Now, how do I see what that path has? If I do ls, which is a short for list, you will have KVL, in my case, KVL binder serve and storage. Okay? So I want to go here. I know that the files, my files on KVL binder serve. So I just change the directory, which is cd, and then KVL serve. Okay? Now, what did you notice? I typed too fast, correct? Super fast, inhumanely fast, as a matter of fact. So Shell and Linux have something that is auto-completion since the 80s, all right? So if you put KV and then you press tab, it will autocomplete for you. Try it. You will see that it autocompletes. CD, KV, and tab. And if you press enter, now you can see that this changes a little bit here. Now it's telling you, now you are not at home, not just at home, but now you are in home, Jovian, KVL serve. And if I do ls, I shall see all my files over here. By the way, can you see this, or should I blow up a little bit I can increase the font. Is this better? Guys, I'm not your PI. I'm not here to judge you. Tell me, like, I cannot see. And okay. So what I want you to do is the following. The slash. That's okay. Because, for example, this is too cluttered. I'm going to do a trick to get rid of this, which is export PS1, not for PlayStation, by the way. And then I'm going to call this equals like this. And now this is what I get instead of this prompt. So this thing here, the $sign is called prompt. I can change it whenever I want it with this notation. If it's too cluttered for you, you can do the same thing, okay? Now, I want to put these things on here, the public binder. Who am I? PWD and ls. Okay? And now, any of you can autocomplete what is this? Well, not autocomplete. You can write whatever you think it will make you remember what this does. Okay? For example, this trick here, port, it will be over here. And I will let you guys to actually put some comment over there. What does this trick does? Okay. So now I have a lot of things written here, and I don't like it because it's already too cluttered. It looks not nice. What should I write? Actually, clear. And this cleans your terminal. Okay. So you can do everything at once. We can print where I am over here. I can check how many files do I have there. And I can navigate over, for example, /home Jovian. And now I can see I have, again, going back to this thing. Okay, and then clear. So far, so good. Everybody got the idea how to navigate? Okay, can you go and actually do these things a little bit more? Like go back, go forward, ls, spring working directory, and if you're too confused about who you are, ask the machine, who am I? And it should tell you Jovian. Might be not your favorite name, but it is like that. Okay, so another trick. You see, ls is nice. It lists all the things. But what about color? If I do dash dash color equals auto, if I recall correctly, it should give me a color over here. Okay? Now, I know this is a trick from an expert going to a novice, and it's like, okay, that's nice and all, but how do I get access to those kind of tricks, right? So usually, all of these things have a help mode. Let's clear this. ls dash dash help. Learn to type. And it will deploy a bunch of different things that you can use. Okay? Now, dash dash help have all these options for you, from -a to -b, and then you can go all the way down here. It will tell you about -c, -1, help, version, tab size. There is a lot of things that you can do over there. I was interested in color because when you have -c, it's different when you have dash dash color, and it will tell you how to use it. It's a little cryptic, but you can find a lot of different examples over the manual. Okay? This brings me to another installment of, let's check this thing. Let's go down all the way here. Down, down, down. Here. So everything in Bash has this order. Like you have the prompt, the $sign, then you have the command, then you have an option, which is just the thing that I did with color, and then you have an argument, which is basically what do I want to do with that file or that position or that path. Okay? This is the image that is basically on the back of your head once you are accustomed to use the shell. Okay? So this is exactly what I did. Let's clear this. Here. ls dash dash color equals auto. Okay? Now, this is the prompt. This is the command. This is the option. And I didn't specify an argument here because I can do the same with, for example, Jovian. And you see it colors them differently. But this is the argument. When I do not put an argument in front of ls, it's assuming like here, where I am sitting down in my working directory. So basically, ls is doing this. Okay? So this is part of the awesome part and also the danger, because it assumes that you are interested in doing something where you're sitting in your printing directory, but it also can lead you to misunderstanding what the thing is doing, because probably you don't want this list, you want another list, right? So far, so good. Everybody could color their output? No? Not yet. Okay. illegal option. That's interesting. What are you working with? With the terminal of Linux? Mac. Okay, if you do ls-help, it's the same. So you have the -- color. Okay, that's correct, because there is a itsy bitsy difference between Windows, Mac, and Linux. It's like not all of them are uniform in their options. So when I do ls minus, let's say, G, that didn't work. -2. It says this, invalid option or illegal option, right? So this is why I'm asking you to do ls-help and look for this -- color. Should be on the very top after the C. In my case, because this is Linux, it tells me like you can do auto, always, or never. You can enable it for all the time. Abel, can you color it? Well, not yet, but do you have the option? You have it. Okay, for me, to use it, I have to put -- quotes auto. If I just do auto, it will not do things, I think. Still, it knows. Let's keep it like always. Well, all right. Now, another powerful thing about shell. The powerful thing about shell is that you can go back. You know your keyboard always have these arrows, right? Up, down, left, and right. If you type up, it will deploy all the things that you have done so far. All the commands over there. You can go up, 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 all the way to whatever you have done so far. Okay? There is another way to check this out, and you can do history. If you write history, it will deploy all the things you have done so far in a big list. So if you have done 1,000 things, this is not the best way, but it will get you all the things that you have done. Now, you can basically do two things with this. You can copy paste whatever you want to do, like I can copy paste here, ls color auto. Okay. And that will actually go again, right? Now, there is one more thing that you can do to repeat an action. If you have like 1,000 actions, you can do exclamation point and the number of that action. For example, in this case, let's do 73. 73 is this, 73 is ls help, okay? And it deploys the thing. So this is very quick. If you have an action that you don't remember the thing, I will tell you how to look for it when you like have a vague idea of what you did a little bit later. Okay. So, by the way, Noah, if you're listening, try the GitHub KBL binder serving public. Okay, it's over here. It's on the notepad, the other pad, sorry. Okay, so far so good. Do you need coffee? Do you need a break? Yes. Okay, I saw two hands of yes. Okay, let's have a 2 minutes break, all right, to refresh the air. And I will start with you again going about the different things that we are doing or how to navigate path. The next part is how to create and read and write. All right? It's going to be scary, so brace yourselves. All right. Noah, the ether, the link on the ether path. Ah, that's you. Okay. You see, I can communicate with you all the way there. Excellent. Okay. Is anybody in troubles to spawn one of these terminals? Yes. Okay, you can, if you have a Mac, you can use your own terminal. Just download the materials from the page, from the. That's okay. If you do you have a GitHub account? Did you make it valid on the Class Hub page? Yeah, yeah, it was. Let me check it out. It's like here. You did that, and it's not deploying the Class Hub for you. Access denied. That's interesting. Okay, so you can also use the KBL GitHub that we have available if you want. If not, you have a Mac, you have your terminal, download the material, you're good to go. Good enough. As a matter of fact, that's the thing. Like you don't need the binder hub, indeed. You just need the material. What is this? Okay. Neither the binder, really? Oh, is it you? Is it you? Really? What are you using, a Mac? That's odd. Okay. Give me a second. Okay. Copy. Okay. Sorry, what is your name? Itzia. So can you check this GitHub over there, this link that I just posted here? Go there, again, go all the way down. I'm trying to launch the binder. This is in theory the emergency one. Is still blocking you? Yes? Is the internet? That's okay. In the break, I will see your computer because that's a mystery that I want to solve. Really strange. Okay. So, guys, raise yourself. We're going to create, read, and write documents now. Okay? You have all coffee? Cookies? Good. So, meaning you're ready. There are different ways you can create files. One of those is a very old joke that I like to tell because the command is called touch. Okay. So because I'm old, I like to say you can touch this .txt, and only people of my age will understand what I'm meaning. But you can touch this. It's going over. Okay, you're too young. Anyway, so if you do ls, you will find now that this has been created. You can also touch that. And now, if you do ls, that will be created. Okay? Now, one of the things that I like to use a lot in shell is ls minus LTR. These options, these three options together, is basically give me a list in a list way, in a real list way, order by time in reverse. Okay? I'm giving you this trick because it's something super quick to use all the time. And it will list everything that is in the folder, and it will put the last thing that was created on the bottom. Right? That's something super useful. If you want to do the same, but because you want to know what's the size or organized by size, instead of T, you use capital S. And the biggest thing will be listed at the bottom. Okay? Those two tricks are something that's going to save you a lot of time because you don't want to see the whole thing. You just want to know what was the last thing you did or the biggest thing you did. Okay? So I will put this over here again. Oops. That. Okay. And this one. Whoop. Okay, my friends. So you can touch this, you can touch that, but what about there and beyond? So if you can actually do there, those, C and them, EXT. So here it goes. Do you think I can create 3 blank files on one shot? Yes, you can. So if you do ls minus LTR, you see I created this first, that, there, those, them. This creates files super quick. What's the catch? They are all empty. All right? You cannot, as a matter of fact, you can see here, there is a 0 here. 0 size, 0 size, 0 size. It has 0 bytes. So literally, they are empty. You have something here, you have something here, you have something here. We can actually color it. Equals auto. Oops. There you go. So this color tells me that there is a folder here, and then I have all of these as basically just files, okay? Now, yes. So it does it requires the quote or does it not? The best practice that I will tell you is do what the manual says. So the manual, if the manual says do this on quotes, keep using quotes. Quotes are actually very important in shell. So yes, keep using the quotes. This was just for show. But anyway, so you can see that you can actually concatenate different options for the commands in shell. You can create these, that, there, those, them. Fine. What if I want to get rid of them? There is one command called remove. Okay, so you remove this, that, there, those, them. Voila. Okay, so I created 5 files and I deleted 5 files. The catch to create it with touch is that it's going to be empty. The danger with remove is that it removes permanently. This is not going to your, what is the partition? Your trash bin. So once you remove something with the terminal, it's permanent, okay? So please don't remove your thesis or something like that. Very important. Because once you hit remove and enter, it will literally destroy the thing and release that space from the memory, and it's gone forever. All right? Be aware of this because it will come to a moment that you remove something that you didn't want to remove. And there is no one else to blame but you because you hit enter when you're removing. Okay? So one of the things that you should do also is like have a backup just in case. And a backup of the backup. All right. So again, let's do undo history. I can create again these guys with exclamation point 97. Okay. If I do ls minus ltr, I have these guys there. All right. How do I write things inside? We're going to use something that is called text editor. So for you young folk that are here, you never had to deal with this before because you were not born in a moment that Notepad was the best thing that can happen to your thesis. So these text editors are just text editors. You cannot put things like figures. Literally is for writing. So we're going to use something that is called nano. Okay? If you do nano there, it will deploy something like this. Okay? This is calling the nano text editor to open the there file. Okay? And I can write something like, hello, I need to learn to type. Okay? You can write stuff like that. Now, how do you save this change? Is all the way here, down here. You have options. Okay, in this one here, write out is Control for Mac, is Control O, and it changes the thing here. So the first thing that is going to ask you is like, do you want to change the name of this file now that it has changed? You probably just want to say enter. This is the thing I want. All right, and it says I wrote one line. That's nice. So now Control exit is Control X. Right? You enter very easily. Control O to write. You enter, press enter. It says row to lines, and you can get out. Or you can keep going like the Dragon Ball is on a castle. Okay? And you can keep right on. Control X, and you're out of it. So this is the second thing that you can do with Nano. You can create out of thin air whatever you want. So Nano this.txt. If I do this, Nano will create a file called this. I have it here. I have the title over here, and I can start writing again. This is writing on the wall of Nano. Okay, there you go. So Control O to write, enter, row the line, and exit. Okay, so far so good. Were you able to create a file? You have trouble exiting? Did you hit Control X? Ah, that's curious. Okay, so what? Again. Thank you. Same there. So you type nano. that .txt. Now, what do you hit? Let's say like gibberish here. What do you hit? Huh? Okay. So Control X like this. Okay. Wait a moment. Okay. So pretty much everybody was able to run Nano and run Touch, correct? Now, there are different ways you can visualize the contents of a file. There are there are three commands that you can find very useful. One is cat. Okay. Cat will print the things here on your terminal. You can use head. And you can use tail. Okay. You can see here that the three of them actually print the same thing, but they are commands also from the shell. You can modify the behavior later. But right now, according to my clock, it's time for a break. Okay? I mean, a break of 10 minutes. How does it sound? Okay? All right. Any question, you can throw it at me and to my assistant, Dr. Ricardelli. All right. Let me check this. Okay. So in YouTube, they didn't listen too much. Apparently, I have to speak louder. Okay. So I was telling you that you can see inside of a file using cat, head, and tail, right? Now, as part of the power of shell, you can combine pretty much everything with these things. What do I mean by that? For example, let's say you can do history again, okay? But you don't want the whole history, right? Because you did 1,000 or 2,000 different orders, right? What if it's the last thing you did? Okay, let's clear this. History, pipe, tail. This symbol here, this bar, is called pipe. So what this will do is to redirect the output of the previous command into the new command, right? So I'm telling shell, give me the history, that output, pass it through tail, and obviously print it on my computer, right? So this is different to do the whole thing of searching all over the place for what you did last time, or even better, what about the head? Okay, you can see the first thing that I did there was cat /etc/ os release. Now I can again invoke it with !1. And this command, specifically this command, will tell you what type of thing are you working with. In this case, it's an Ubuntu version 18, very old Ubuntu, but long-term support, and so on and so forth, okay? Now, this is the real thing that I wanted to show you was this part here. Head or tail can be combined with history, or can be combined with lstr head, like this. Even better, head, help, for those that can check it out like that. It has also options like n. This is the favorite of everybody. Like, let's say I want to do the very first file. Head -n equals 1, or let's say space 1. Let's clear this thing because it's too cluttered. Okay. The very first thing that lstr will give me is this thing. Now, give me 2. And it will tell me you have a total of 50,000 bytes, and this is the very first file that you will find. As a matter of fact, I know that this is a folder. If I put -f for folder, it puts a nice thingy here, or you can do it with color. It's all the same. Now, what about tail? Tail also can be modified like this. All right? You can do it like that, very easily. It's the same with history, it's the same with everything that you can do. This is very easy also to do with cat. Cat readme, for example, is a bunch of things that I put there. Maybe I just want to see the head, the first 5 lines, and then doesn't kind of. All right, this is the first 5 lines. 1, 2, 3, 4, and 5. Okay, go ahead, explore it with different things over here. You can, for example, try to see what's on the license with the head, right? Let's deploy the history so you can see it. And let's deploy it with tail -n15. So I've been doing a lot of stuff, as you can see. And this progressively is going to be longer and longer and longer until you reach like 1,000 or 5,000 or 10,000, depending on how much you are repeating one or the other or the other or the other command. Okay, very good. So far you have mastered already ls, cd, cat, nano, head, tail. There's another things that I could tell you to do, but if you already do the exercise of head and tail, like combining the pipe with cat, that's fine. We're going to do now another thing. We're going to run this here. As you can see, the Jupyter Notebook, if you double clicking the things that you have here, it will allow you to create, to visualize the file usually, and you can edit this file here. This is better than Nano in some sense because it has colors and more control. Still, is a text editor, okay? So we're going to use this small script that I created here because we're going to download the actual data if you don't have it. So to run this, you already know how to do it. So how did you run your first program? Writing what? You can write it on the Etherpad if you were too shy. Like, how do you run a bash script? Echo prints the things in your terminal. Bash. The keyword is bash. So let's do that. Bash. Let me remember. It's bash, and then copy and paste. Control copy and copy paste. And enter. In my case, because I will do it file 2, you will not have this problem because I already download this thing here, and it will open again, and you will have this shell lesson data folder. Okay? You just have to do bash if you're inside of the bash get data.sh. It should start the download, and after a couple of seconds you should have it there. So what I'm interested in you to get is this folder shell lesson data. Okay, did you get the data? Yeah, okay. Everybody has it? Okay, let's go into it. The shell, and you should be able to see two things. You should see these two different folders, okay? You got it? Not yet? Remember, print working directory, if you don't know where you are, you should be inside of shell lesson data. Exercise data and North Pacific gyre. All good? Excellent. Let's go to exercise data. Okay? Now you have here different things. Alkanes, animal counts, creatures, numbers, writing. So if I want to know if any of these is actual folder, I can put -F, and it will put a mark on those that are folders. I can do the thing that I like most, just color them. It depends. By the way, I don't know if any of you is colorblind, so I apologize for not asking. But you should see some color, not the same I'm seeing. Okay? So let's go to my favorite, which is creatures. You have 3 different files, all .dat, D-A-T. All right? Now, let's say that you want to see all of them at once. What can you do? Imagine that just like Touch, I could put different files one to another. Can I do the same with head? It's possible because it's shell. So for example, if I go and do head, basilisk, minotaur, and unicorn, remember, I'm hitting autocomplete. This is why I'm doing things super fast. So I just put UN and tab, and it completes everything. All right. So here you have now the information of the first 5 lines of each of these different files, right? Basilisk that says, oh, look, common name, classification, update. Minotaur, common name, classification, like Bos hominus. Unicorn, because Ecus monocerus. All right, somebody got the data about these difficult creatures to get from, right? For example, I always want to ask, like, from my Arabic friends, which are the creatures of the myths, and I think one is the jinn, which is like a genie, right? So we can create genie. Let's do this, like Touch genie, that. So I create another file, but obviously this is empty. Okay, that's fine. And you can go very quickly over all of them if you just want to see what's on the top of these files, head. If you want to go and see what is on the tail, the same thing, right? Now, Genie doesn't deploy anything because it's empty. That's fine. One thing that you will see now is that now I have a very long line, right? So I can go with my arrow all the time to the start of the line. And if I want to go all the way to the end, it's going to take me too long. So what can you do? There is Control A to go to the first part, or Control E to go to the end. See how it jumps. Control A, Control E, Control A, Control E. Okay? That is going to give you some speed up about where you want to go. Start of the end. All right? Now, do we have some bioinformatics in the house? Bioinformaticians? Yes. Okay. You know that these are sequences, right? Give me a, I don't know, data box. Do you think these things are eukaryotic, like to have a data box? Okay. So let's say that there is a pattern inside of each of these DAT files that we want to retrieve. All right? So what would you do as a bioinformatician? Do you go inside of each of every one of these files and try to find it by hand? No, right? You try to use any fancy tools that you want to try. Because let's say if we do nano and unicorn, so it's 163 lines that I have to go over and try to find out where is the sequence that I want, the sequence of letters. And this is just 4 sequence of letters. All right? So let's say, I don't know. Let's try to find three G's together, just like in this thing. Okay? Now, how do I do that? There is a command called grep, G-R-E-P, all right? Now use double quotes, and let's put GGG. Now, unicorn, if we just try to find it in unicorn, it will find it there. Three G's together here, three G's together here, three G's together here, and so on and so forth. Okay? You see, you can find anything with grep as long as you know the pattern that you're looking for. But now is when everything comes together, because now we can pipe this and say like, hey, give me just the first thing that you find. Is this line. Give me the last thing you find. Is this line. Okay? So grep will get you what you were asking to get you. It's a sequence of characters that it's actually trying to find in one of the files. All right? Now, what if you want to do all of it in all the files that we have? We have 4 files. Okay, let's remove Genie because it's not a real thing. Says the guy that's reading unicorns. Okay, but the thing is the following. What can we do when we want to do everything in these 3 things? This is when you come to realize that Shell has wildcards. What does a wildcard mean? It's going to try to find whatever you put with the wildcard together. Let's exemplify that. So if I want to see, for example, just cat, and instead of going basilisk, minotaur, or unicorn, it will deploy everything together. But you can also do, let's call cat asterisk dot dat. This is telling exactly the same thing to Shell. Okay, the wildcard is whatever is in front of dot dat, use it with cat. Okay, this is the command that I want to execute. Then this is the wildcard and dot dat. And it will do exactly the same thing. Now, if you want to pipe and grep something like this, TA together, let's see if it finds it. And it does. Okay, in which one, you don't know. That's the only problem. Okay? Because cat will concatenate everyone together, all the files together, and output something. So if you don't care where it finds it, as long as it finds it, that's fine. But if you want to get more control, then you have to do something more specific to it. Okay? Now, let's go back. How do you go back? One level up, dot dot. Right? So I'm back one level up. If I want to go back into creatures, cd creatures. But if I want to go back 2 levels, it's dot 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 slash dot dot. Okay, navigation is something pretty intense. But the point is now, I am again back in exercise data. Now let's go to writing. All right, I am now in writing. Okay, writing, go cd dot dot, and you're back in exercise data, and then you go cd writing. Okay, and in writing you should see haiku and little woman. All right, you're there. Now, what is a haiku? It's a poem, if I recall correctly. I'm not very well doctored on that. But now you see that haiku has a structure. It has some kind of repetition and patterns, right? So here, what I want you to do is to use grep and try to find, for example, how many times, sorry, will it appear that is the not word. I want you to get this with grep. Okay, that's your exercise for now. In the haiku, do grep and tell me how many times do you see not with grep. Yes, 3 times, right? And you can count them by your eyes, which is nice. You can do the same with any other word that you see here. For example, thesis, not found, or something like that. You can count it with your eyes because haikus are supposed to be very short poems, right? With a rhythm, with a metric, and so on and so forth. The thing is, if you ever read Little Woman, you have 4 characters that appears throughout the whole history. I do not remember the names of these girls, but we can ask ChatGPT about it or any other. So, right, yeah, let's do that because I really don't remember. Yes. Oh, come on. All right. Okay. Go, 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 go. Yes, thank you. What is the name of the sisters on Little Woman? Meg, Jo, Beth, and Amy. All right. Now, I want you to search for Jo, Amy, and Beth in Little Woman using grep. As a matter of fact, just search for one of them if you like. Jo. J-O, yes. Search for, do a graph for Jo with Little Woman. It's like too long? It includes John. That's a good observation. How can you fix it? So if you just put J-O, it will include John or something J-O, right? Like Mojo. Aha. So that's the trick. It's like you can do the trick with not with a haiku because it's like 3 words that it repeats because it's a short thing. But if you're searching through Little Woman for Jo, how many times do you have to count, right? And the other observation is like if you do grep Jo in Little Woman, you have Joe's, and then you have for some reason John here, right? If you see these here, that shouldn't count. So there is that. We can fix it by just adding, for example, Joe space, and then it will appear to find Joe space. We will left out some Joe words like Joe hash s, Joe's thing. All right. The thing is, you still haven't tell me how many times did you find Joe in the text. It's too long, right? So what we're going to use is another tool called word count. Okay, WC or word count has different approaches. Okay, so you can ask for lines, characters, words, and so on and so forth. Word count is very powerful, but the most used thing of word count is to count the lines. So for example, if you do grep Joe word count minus L, that Joe space appears 649 times in the text. Okay, it's all the way here. Let's do it one more time here. There you go. You see? Now, this is your exercise. Do the same thing for the 4 sisters. You have Meg, Joe, Beth, and Amy. Do the same thing for each of them. And tell me who's the most, who's the favorite of the author? Which one of the sisters? Yes. Yeah. If you use word count, for example, just by itself, and then, for example, haiku, it will give you three different columns. One is related to the lines, one is related to the characters, and one is related to, it was line, characters, and columns, if I recall correctly. Words, yeah. Because, for example, minus L, this one is the first one. And then minus C is this one. And if we go dash word count minus L, minus help, minus C is byte counts. You have words here if you want to do minus W. W, haiku. So that's the thing. If you just invoke basically WC, it will give you the lines, the word count, and the bytes. So if you're interested of, you usually just interested on one of them. In the case of the 4 sisters, by the way, did you find the number of times each sister is cited in the text? You probably did already. So who's the favorite of the author? Well, I'm not a Joe. I'm more like an Amy, but at the end of the day, that was the choice of the author, right? Like Joe is Joe's story. You can tell that from the data. Even if you have not taken into account all the times that is Joe hyphen S, it still overwhelmed me more cited than the other sisters, right? So in that sense, you can try to do the same with your thesis and tell me who's your favorite citation or your favorite word, even though like I have some biases for that, like meanwhile. How many is like meanwhile or novelty cited in your thesis? Okay, so far so good. Everybody now can grab a pattern and count it how many times it appears. Excellent. So you can create, you can write, you can navigate, you can even tell me who's the favorite sister in one book, very long book, in what, 5 seconds? Sort of, right? All right. So you can even concatenate different commands, one with each other. Fine. How long will it take you to read Little Woman? And keep count of the sisters. Pretty long. I mean, I haven't read the book, but I see it's like this thick. So now you're getting the feeling of how is a data science work getting to, right? This is how fast you can go. And this is just shell. This is a very easy implementation of a language. Now, what do we have left to do? So we can go inside alkenes. And now we can practice some more things. Now, this PDB, if you look at it, And if you are from chemistry or biochemistry, you know that these are an old format of how to embroil basically the X, Y, and Z coordinates of a chemist, of an element. In this case, a molecule. All right? So for your next exercise, please go about it and get me how many hydrogens each of these things have. You have 1, 2, 3, 4, 5, 6 files. So how many of each have hydrogens? How many hydrogens have each file? That's what I wanted to say. Okay. Again, use your friend grep, use your friend pipe, and use word count. And let me know. Alkanes. All of them have 56 in total? Yes? There you go. We have 164 over there. All right. So you're starting to get a feeling of how it works. Great. How about here? All good? Ah, you have issues to connect. Okay. Oh, okay. Don't worry. We can try to check it out on the break. Okay. Okay. Everybody got around 60 something, right? Yes? Yeah? In theory, yes, but you know, like sometimes somebody does something. Okay, so far any question? You have everything done very quickly, as a matter of fact. Okay, all good? Okay, ready for another break? Yes? You look decaffeinated. Okay, so let's take another break. And yeah, if you have any questions or difficulties, let me know. Where is it? Break? Here. Okay, so a brief pause just to tell you about Glossario. This is a carpentries project that is basically a big, very, very comprehensive dictionary of different terminologies that you probably are not aware of it. Sometimes I'm not aware of things here and I come here. And the beauty of it is like it's usually also in your language. Okay, it has English, Spanish, French, Hebrew. I don't know how to pronounce this, so I'm not going to try it because problems. Deutsch. I don't even know how to pronounce that one either. But the thing is, like, you can find all different things, terminologies in different languages. I guess you can find it also in Arabic, and it will be explained in your language. Okay, if you can read English or French or any other, like for example Spanish, you can go and check it out. Like for example, in the C, it has different things here, explaining Spanish or explaining Portuguese, just different terminologies, okay, that you can find in data science. When you have any doubt and looks like it's an IT related term, you can come here. I will put the link over here so you can choose your language of preference. Okay. So we're going to enter in another phase. We're going to do something that is called for loops, okay? And with the for loops comes great power and great confusion. Why? Because you have to literally speak the language of the computer. You have to have the logic of a computer, let's say. So in this case, we have already working here in exercise alkanes, okay? We have cubane, ethane, methane, all these anes. All right. So you already tried to get how many H's are inside of each of these. Cat, cubane. And I ask you to go and calculate how many of them, right? For all of them, which is something that we already see with the star, with the wildcards. It's very easy. But it doesn't tell you how much per file. Okay, how do we control that? We either go each time for each file doing the same command. So you repeat 6 times the same command. So that's not very useful when you have 1,000 files. Let's say not even when you have 10. I get lazy when I have 5. All right. So how do you do that in a certain way? You use something that is called for loops, or loops in general. The for loop is the most friendly of the loops because it has a clear syntax, okay? And I will show you that in a moment. Let's clear this. So in this case, for example, if I do for file in, and I can copy paste all of this, then you can put this here. What is the name of this, by the way? Semicolon, right? You use semicolon, then you say and do, you tell it, do the following for ink, for file, ink, cubane, ethane, methane, blah, 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 all of them, do the following. Grep, and I want atom. I know the keyword atom exists in all of them, right? And even better, let's test it first. Echo file. Now what I'm doing here is putting this $sign before, because this thing, it will tell for, like, I am asking you to tell me about this thing here, the name that I've told you. For element in my list, print the name of that element. Okay, this is what it means. And it needs the $sign because it will then tell for like, I am asking you about that file name. If I do enter here, I get this. Okay, it's the same list as if I do this, but with less detail. Now, I can do even better. What can I do even better? For file, instead of doing the whole thing, I can get rid of this and just put ls. Because I know that ls will make a list. So I don't have to write each of every single one of them. Oh, didn't happen. So what is missing here? Yes. Yes. So there are two things here. One, why it didn't work? Because I need these inverted quotes to actually tell, like, there is a command inside here. So for file, in this command that I'm putting here, echo that file. And now it prints the file, okay? Moreover, can you do things even more specific? Yes. Because now with ls, we have asterisk.pdb, right? Let's say Control A, let's conserve this in a moment, and let's do the following. If I press Control R, it goes into reverse search mode, meaning that I can type again something that I did before, and I want touch. Okay. So here I press enter, and I create now what I like to call noise. Okay. Once again, what I did was the following. I press Control R, and this is reverse search mode. In reverse search mode, you can type again the same command, and it will deploy something here. Like in my case, it was touch. If I press enter, it will execute that one. It's not always perfect, but it's faster, because if it was something that you clearly remember, it will go fast, okay? Now, I created there, those, and them. If I do the same thing with this, I will just get those that are PDBs. If I don't take into account the .pdb, it will include those txt that I actually enabled, all right? So in this case, if we conserve this one, and then we tell it like echo that file, and then for each of the things that you want it to do, you have to add a semicolon, grep atom, and then word count minus L. Give me something. And I got trapped here for some reason. Ah, yeah, I know why. So what is missing here is actually like, where is grep going to work? Something like that happened already. Like if you do only, let's go simplify this. If I do just cat, it stays there forever, right? Have you run into this? Yes. So if you get stuck, press Control C, and it will break the problem. Okay? The other way to get out of this problem is Control Z, and it will tell you it's stop. Okay? One of your colleagues actually ran into this problem a moment ago. And I just ran into that problem a moment ago because I didn't put something in the loop. So what I did here was to tell for do echo file and then do this, but I didn't tell grep to work in what file. So here I'm missing a file name. And that file name is actually $file. Okay? So with this, it works. It's an ugly format, I know, but this is very quick. Now, for each of the different files that I have with PDB, I know that there are 16 atoms in Cubane, 16 lines that have atoms. 8, 5, 26, 17, and 11 for each of them. Okay? So how should I read this? For each element in my list, let's say ls, and if I want to be very specific, in my list of PDBs, do, and here, for example, you can press enter, and it will happen to be inside of the for loop. This will drive your computer into programming mode, and this is what this means, okay? This sign. Now, what I want to do with that do, I want to echo the file. I can enter again this, and then I can grab the atom of that file. And when I want to be over with the loop, I just write done. Okay? This is the way you can think about it. How do I write this? For each element in my list, do stuff, and when you're done, you literally write done. Alas. Okay, for your next trick, you're going to do the same. Yeah. Look, we're going to do even better. Let's clear this. Now, for element in ls. Now, here, after the semicolon, you can press enter, and you will enter the compute mode, okay? It means that you're still not executing the for, you're just giving the orders. You're just specifying what you want to do. So in this case, I want to know the name, okay? And when I go to the end of the line, I like to put the semicolon to make it very clear. Then you press enter. What? Ah, yeah. So for element in ls, what was missing here, it was do the following. Then you can do echo element. You need a do. The thing is, you need a do to actually get the for loop going. Then enter. Then you can be over with and say done. And once you hit done, enter, it will execute that order. But if you go back, it just writes it in a single line. So while you are with this notation here, this greater than, you can put all the things that you want to do with that for loop. In this case, I can do echo element. I can do, again, the do. Do not forget the do. Element. Then let's do grep from, let's say, h. Let's grep element. And then word count all the lines that have h enter. And if I am done with that, I write done. Okay, so I have nothing in the txt files that I created, but I have different numbers of h element. And this is the way you work with for loops. Okay, this is a way to work with for loops. So let's put this over here. Okay. All right. Now for your next trick, maybe not here. So for the next trick, we're going back to shell lesson data, and we're going to now enter into the North Pacific Gyre. All right, cd North Pacific Gyre. So you can do it in one shot, or you can do it in many shots as you want, but come back here to shell lesson data and then go into North Pacific Gyre. All right. Everybody there? Okay. For those that you are already there, tell me, what do you see in the sh files that you have there? You have to good diff and goostats.sh. Okay, go with nano or do a cat, check it out. Okay, you all check it out, the two different things. Okay, so here you have an example of what is a bash script, a more advanced bash script. You already have one. That was the first one that you did with echo. This is a more advanced scripting, but it has two things that I like. One is the if statement, and it's checking stuff. Okay. So we just check, for example, for loop. There is another statement that is super useful, which is the if statement. Here you have this part here. The very top has a hashtag. I don't know how people call it these days, but the hash thing that you see here, that is something that is called a comment. Okay, so inside of any program that you want to write, you will always have comments. It's always a good thing to have a comment. Why? Because the future you will try to read that program, and we have to remember what your past you were thinking about that program or what was actually doing. Okay, so you can create these comments using this hash here. And this is very clear that it's checking the right number of input arguments. What does that mean? That this good diff sh actually is taking two things into account. One, file 1 and file 2. As you can see here, this one is actually using the if statement. So in the if statement, it's telling like, hey, if you see from the prompt a number equals to 2, then you have a good call, okay? And then the difference between two outputs will be if you actually create the first input and the second input, and then it's like, hey, these files are identical. What does this mean? This is a lot of mumbo jumbo, I know. Okay, let's go step by step. This program is run this way. Bash good diff sh. If I run it like this, it's telling me you are lacking two things after this. You have to use good diff and then file 1 and file 2. Meaning I have to do good diff, this one, and this one. Okay? If I do this and press enter, it then computes the difference. Okay? So let's go back one more time to check it out. The first part of good diff is actually taking into account that you complete the sequence of things that has to happen in order to use this thing. So it's asking you, hey, give me two files to compare. If I cannot have two files to compare, I cannot run the program. This first thing will actually exit if you don't complete the two arguments. And this is actually comparing the two files that you're giving. What I want you to notice is that in this notation, this file here is the $1. That's the first input. And this one here is the $2 input. This is the way you can talk to the computer and tell it, hey, this first thing is my first argument. This second thing is my first argument, and I'm calling them to be inside of my file and my program. Okay. So after it checks for that, then it goes to this thing. And then actually it just prints a random thing that is literally a number that the computer generates. It has no meaning. This is why you can run it 10 times and it will be pretty much the same thing. Okay, if we run it this like in a for loop for iteration in, let's call it from 1 to 10, we can do this here, do this, and then done. It will run 10 times, and no number will be actually the same because it's a random number. Okay? So this here is called actually a comparison. And you will need to have this kind of comparison when you're trying to get something out of it. But what I wanted to show here actually is how do you use several times the same script. In this case, as you see, you have for each iteration from 1 to 10 times, do this thing. And you can do a for loop inside of a for loop to go all over the different files that you have inside of a folder. Now, is this the way you want to work? Maybe not, maybe yes, who knows? But this is how you execute these kind of programs. Now, we can create actually our programs. In this case, let's call it nano my program .sh. So first thing first, what do you want to do? Do you want to do a for loop or do you want to do an if? In this case, we have been doing for loops, so let's start with a for loop. For element in ls do echo element. Done. Okay. Do you have the colors too? Now, you might be wondering, why do I have the colors now? Because this name .sh is actually recognized by the computer. So it's actually telling the computer, hey, this is a program. So give me some color here, please. And colors make things actually easier. And this is the way you can start writing your own programs, okay? So let's call it like this, and write it, and then exit. Okay, and it runs like that. So I just created a list of things, okay? So if we go overhead of this thing, and head over this other thing, okay, so for your task in this thing, you have to modify this. Where is it? You have to modify this program in order to know how many lines does each of the files have. Obviously, only the txt files that start with nano. And then after you finish that, we will do some grepping with that, okay? So in this moment, your exercise is modifying this and get it to work just to know how many lines for each of the files there are. How many lines each of these files have? Yes, tell me. Can you write it on the chat or because I cannot hear you all the way down? What do we use to do the like? You're there. Okay. So this is the basic skeleton. What I want you to do now is to add another command that is going to take each element and query how many lines there are for each element. Which indeed we can do like this. Okay. Pretty much you get the gist of that. So almost, if I'm not mistaken, everybody has 300. Bash, my program does sh. Actually, not everybody has 300, right? So there is that thing. What I want you to try now is to add another command, and I want you to get inside of that. Here, let's clear this. So we have this good diff, right? Now, in my program, I want you to run this program inside. How? Nano, my program. So now that you have each of them, oops, I did one. And let's just make some other accommodations. .txt. Okay. Let's start with this guy. Okay. What am I doing here? Who wants to tell me? What am I doing? So here it goes. Like for each element in my list that it ends with .txt, I'm going to do the following. I'm going to print that name of that element. The second order or the second command is going to tell me how many lines each file has. And the third one is going to try to invoke bash and run good diff. And it's just going to compare this file here with element, with everybody. It will print some random number at the end of the day, but it will tell me who is or who is not the same as this. And yes. Yes. I mean, it will be just one single run of everybody versus this guy. Okay, so it will be him by itself, the same file versus the same file, and then this file, this nene 1729A versus everybody. So let's see if it works. And it goes like that. So you can start beefing up your program like this. Okay? It will start doing more and more commands. And here's the trick. If you're writing this, let's say you don't want anymore this one here. See how it changed color? This is because now it becomes a comment. So the comments are very useful because it's like, here is a comment. And let's just silence this. Okay, if I put that hashtag in front of the command, it will silence it, meaning that it will not execute that one. It doesn't make it, it makes it inactive. So every time I run this, now I have a different thing. You see, it finds itself to be identical to itself, which is normal. And then it prints a bunch of random numbers. Okay, you're getting the feel of it? Nice. Uh-huh. What line do you not understand? Before done. Okay. So the powerful thing about Bash is that it can create by itself. It can call another programs inside Bash. Okay, this is a program calling another program. So in this case, for each element in the list, it's going to print the name of that element, and then it's going to execute this program here. I'm telling use Bash to execute this program, and this program takes 2 arguments, which is one file and another file, and we're comparing them, all of them. Yep. I will put this into the Etherpad. Okay, like this. Save this as my program.sh. Okay, write out and get out. So in this case, you can compare all of these files super quick. Now we only have one that is not. We have this file here that is not 300 lines. So what should we do with it? Should we erase it or should we edit this thing? I mean, we can check it out, what is inside, and then decide what is the best way to deal with it. So let's check it out. Nano, why is this thing different here? It has a bunch of meditions. These are basically numbers and then nothing. Oops. All right. I can remove it or I can rename it. So by the way, I didn't tell you this, but to rename something, if you don't want to like completely kill it, you can move it. You select the file and then you give it like, this file is auth. Okay. This will rename the files and it's better than sometimes just kill it. depending if you are very sure that you want to remove it, then remove it. If you want to kind of conserve it, you can rename it with move. MV is for move. It also moves the file to wherever you want to tell it can go. But that's another story for another time. Okay. Now, if we do bash good that. Okay. So for these files, for example, we can actually do these statistics, and we can try to make, for example, this run like this. And it created something new. Okay. Here you have a string of different things that has happened inside of that file. Now, I'm going to explain whatever is happening here. So the thing is, like, you have two files, all right? It's actually telling me like I need two files. It checks for that. If not, it goes away. Fine. Then it waits for 2 seconds. This is the sleep command. It just wait a little bit, and then it starts to do these commands here. Now, I don't have too much time to give you all of it, but let's read it. Let's read it together. What happened is, like, it will take the first 3 lines for the first file that you are putting inside. Okay. Then that output will be passed to cut, which is another command. Which guess what cut does? It cuts something from the file. So it will actually see if there is a comma there to separate the values, and then it will return just the very first part. Okay. Then that output will be sorted, and then that output will pass through something called unique, which is like, give me non-repetitive values. And at the end, it will output that to a new file that is the second file that I just told you. Okay. So this one is a series of things that you can do in one line only. And this is a program already. Okay. I know it looks very complicated, but it's a series of commands that you can actually give to your computer to do for you in bulk, right? So you can just take this and try to do a for loop with it. Get out. Yeah, the changes. Okay. So the way to use this probably is to call this better like that and say out, and then this thing. Okay. Now what I want you to do is to modify your script to do this line and to save it, because now it's going to generate this out from the other files. Okay. This is the original file. It's going to get processed, and you're going to get some unique values from it. All right. So I repeat the task again. Go and modify your program already. What I want you to do is to now use GUStats, check for each element of the loop that it goes into GUStats, and generate an output. All right. Don't overwrite what you have already, but just get a new output out of it. You can put a prefix like output dash, and let me know your doubts, because when you're trying to write this, probably you will find some doubt. Like, how do I write this? Bless you. Okay. Did you arrive to the same thing? Is, is this working for you? Were you able to run it? All good? Okay. So those of you that were able to run it, now try to do the same program, but now for the Little Woman book. Like just get the names of the Little Woman characters, count them, but now in a program that you do bash program Little Woman, and it gets everything out. Okay. For example, if I do this, bash my program.sh, it goes and starts working, and it's telling me the name of the file, how many lines the file has, and it's creating in each step a new file that is the output. So I here have all of the outputs. And even have an output of an output, apparently. Because I already have process one, it goes there, and it takes the output of the output and makes it again. So you have to be careful when you do that, because I am actually telling the program, like, for everything that is txt, process them. I actually could have done something more like this to make it even more specific. If I do this, it just takes everything that starts with N-E-N-E, and then whatever comes after, it has to end in .txt. This is more specific. All right? Let's copy this one into the Etherpad. More. Okay. So if you reach this part, now what I want you to do is to write a program that goes basically and search for the name of the 4 sisters in Little Woman. But now what I want is a program. The program must basically grab each of the names in Little Woman and then tell me how many times each of the names are actually called. Well, written. Mm-hmm. What's up? You didn't create it? Ah, all right. The names of the sisters. Here. Meg, Jo, Beth, and Amy. Okay, let's navigate to that. Control. Yeah, this one. Yes. So where am I? Framework and W. So let's go back to exercise and to writing. It is little woman, right? Okay. So give me ideas. Nano my program .sh. All right, guys. What's the first thing that I should be doing if I want to get all the names at once, or at least to do the same thing we did before, but now with a program? What should I write? A for loop. Okay, we start with a for loop. So okay, for name in. What should I do here? What should I write after in? What kind of list do I need? This is little woman again. Eh? The names. Yes. So I can do Joe, Amy, Beth, and Meg. Okay. With the slash, you mean? With the quotes? The other one that is like slash. Ah, you mean like the inverted thingies. Okay, these ones, when I use this, is for a command from like ls, cut, more, all of those. Here, right now, these are not commands. So I can skip using that. Okay, those are my names. Now, what should I do next? After do, what I want to do? Okay, I can do echo name. I will have each name written in my terminal. Nice. Okay. Next, what do I want to do? WC. Yeah. We can get WC minus L name, and again then the book name, which I have to actually get from here. I copy and I paste it here. Okay. Okay. What else? What else do I need for the for loop? I can just do done here, right? Control O to write the program. Control X to get out. That's interesting. So I could not use it like that. We will see how can we do that. Should be something like this. Don't like it. Okay, let's try with this. Doesn't like it either. It doesn't like it. That's odd. So I cannot take it like this. Wait, I might be actually getting the wrong problem in the wrong line. Because usually what we have to do to grep the name out of little woman and then pipe it to word count minus L. It still might get me an error. Oops. So my first error here was that I was not using grep. I'm grepping the name out of little woman and then I want to count it. Okay. Let's write this thing here. Now let's try it. Okay. It didn't like the way I write the name Joe and Meg. So I can just take this out here. Sorry for the color, I didn't choose the color. So let's go back one more time to the original writing. So if I comment this line and I just do for name in Joe, Amy, Beth, and Meg, let me check if this works. And it does. Okay. So we have already a working program just to count super quickly what is about this thing, right? If I want to go over a series of characters that I can actually find inside of a text, I can go with Joe, Amy, Beth, just written like that because there are characters, there are not commands. When you want to do a command, then is when you use the inverted quotes, okay? Then I am doing an echo name grep the name out of a little woman, and then could just give more space. Right? Oh, exit. Okay. Exit. And I can check for each sister how many times is actually getting attention of the writer. Now we can modify this even further. So what happens if I don't want to just search Joe, Amy, and Beth just in little woman, and I can just change the name. This little change that I did here, the $1, it will allow me now to enter whatever I want after I call this program. What I mean by that, I will show you. Is control. Oh, yes. Okay. So far, if I run this program like this, it's going to get stuck and do nothing. Okay. I'll be waiting until my death for this to actually end because I didn't give one single command correct. Now, Control C to escape this. What I did was actually I have to put something next to my program, an argument, or at least the file that I want to process. So, in summary, this change here that I did is for you to actually allow the program to read whatever you want. Okay? So this means the first thing after the name of this program is your input. You see? It's easy to understand because at the end of the day, what you have to do is to give an input. Now, where do you use that input? Because now you can write a program that can take an input from inside. And if you have to process over and over again any file with the same program, you can do it very quickly with this. Even more, you can actually go nuts and say like, hey, I just want to do grep name of a second thing and then do the same thing. You don't have to do the same thing over and over again, right? But you can have two different inputs in the same program. This is exactly what we did in the other exercise with all the NA files. You can have two files written by the program. Oh. And in this case, I go and search for the same four names each time in two different files. I can give haiku and can give little woman. And then it just processes all of it in one shot. Okay, so if you have two different files that you kind of know that they could be working together or they're related, and you're searching for the same thing in both files, one batch script, 5 seconds later, and you're off. Okay? Yeah. Okay, so you're talking about more stylish thingy. It can be done, yes. So, in that, okay. You have the name here. You can do echo. First of all, in order to do what you want to do, which is first haiku and then little woman, you have to assign these values to be safe in something where we're going to call variable. And this is variable 1. It's going to be written like this. In order for you to create a variable in bash, you have to write it like equals $, and then parentheses. Okay? And this will be variable 2 equal $, parentheses. Okay? Now, as any of you, I swear that everybody of you took mathematics, right? So you know what a variable is. It's going to change every time you run the for loop. So the value doesn't persist, meaning that it doesn't live outside of the for loop, and it's going to die once you do that. But this will allow you to do the following. Echo 1 and echo 2, but then also echo variable 2 and variable 1. No. Control override and Control X. All right. So that one is a little bit advanced. but I guess you all wanted something like that. Because now what you're playing here is like you have a variable 1, which is your input. You have a variable 2, which is your second input. And then you're storing whatever comes out of this combination of commands into a variable, right? So etiquette about variables. Please write something that actually is meaningful for you. When you're writing a variable name, don't hesitate to do a long name. Far are gone the times where you have to be actually concerned about how long the name of the variable is. And I'm telling you this because when people were writing things in Fortran, they have to take care of the name because it actually saves memory to have something named X. Those times are gone. Now you can write a variable name and call it like this variable or variable to haiku, variable to book. Okay, you invoke them the same way. Control copy, control paste. All right. The variables have to be very clear. When you read it, it has to be clear what they are storing. All right. Other thing, I know you people from Windows love to put spaces between the names of the files. Scratch that. If you're going to be a data scientist, use underscore or hyphen. Because spaces are going to be your worst enemy when dealing with files and with names of the files. I will show you actually. Control overwrite. Ah, yeah. I will do this. This is going to be all in the other path for those of you that want to do it. Stay there. So if I do touch, for example, this new file, one doc, what do you think is going to happen here? If I type this name into Word, it's going to basically create one file, right? In Word. But in your terminal in Unix, it's going to create all these files. You created this new file and one .doc. Okay? This is why your worst enemy in data science is people that use Windows and use spaces between names. So if you care about your data scientist friend, please use underscore. All right? There is that. And of course, when you are here, the variables have to be clear. You don't have to put codes. And believe me, putting X as a name of a variable is too wide open. You don't know if X1 refers to what when you have to call it again. And maybe it's storing just temperature or just the name of Joe. Okay? So this is advanced scripting. So if you reach awake to this point, congratulations. Because this is the last part of the workshop. Okay, once you master these bash scripts like this, because you can now give input, you can change the way, and now I give you the secret how to store a value inside of a variable, right? So with this, and because it's basically lunchtime, I guess you are decaffeinated and hungry now. So before we start killing each other because we are hungry, you're free to go if you like, okay? So any questions so far? Yes. Okay. Okay. This is a matter of style because here I'm asking just for two files, right? If you want to get all over the place with all the txt files, it's better to go over here and say like, okay, just ls all files. That's one. There is another one which you will find also in the documents on the of the workshop. In the where is it? In here, in the in this exercise that you can go over and do, but in your time, there is one that it will allow you to say to the shell like everything that I put after this bash thingy, like right. Nope. So for example, if I do bash my program and I have to put several files after that, I can do that. It's in the document. You can do something like that and you can put as many files as you want. But for example, if you're completely sure that the only files that you have there are the PDB files, for example, here in alkanes, if I remove all the txt, I only have PDBs. So in this case, it's better to use something direct like for element in ls all of them or just ls. This will trigger basically the for loop over everybody that is in that file. So remember, like I think it's Occam's razor, like the shortest answer is the better or the quicker path is the best. So the more simply you work, the better, I think. That's my philosophy. But complicate your life as you want. It's your life. Okay, any more questions about this? I already have the glossario for you in the Etherpad. I put all the copies of these programs on this thing. The class hub, if you were able to run the class hub, it will be open for you during the next 2 weeks, I guess. If not, there is the binder, which we already kind of work it with it, but sometimes it's not that stable. But the best thing you can do is basically set up your own terminal in your computer. There is a setup in every page that I could share with you. But yeah, okay, so feel free to contact me if you have any more questions. And I hope everything was clear enough. And please also have some coffee. I can see that you need energy. Yes. Uh-huh. The website. Okay, but that's here. Actually, if you go to the wiki of our page, wiki.biz.kaust.edu.sa, we have training events here, okay? In training events, you go to Shell Data Science. It will take you to this website. The Etherpad is here for everybody, even people that is outside the university. This is public. And here is the material. In Shell Novice, you click, and you're in the software carpentry. And you will find the data that we use today, many more things that I didn't show you. So if everybody got lost today because my English is the worst, or I wasn't very clear, or was going very quick, you can read this, and it will tell you the story about this data. This data came from a marine scientist that her name is Shelly? No, Nell. So Nell has a problem. You can solve the problem with Nell. This is a whole storyline, okay? And it will take you step by step at your own pace, with your own time, all right? and it will go over the same data, same exercises that we did. It has some other exercises over here in yellow. All right, try to do this. If you basically fail, don't worry. Nobody's assign you any qualification. There is no test. This is for your own knowledge, and you can go and see what's the solution to this. So if you try to do it by yourself and you fail, that's okay. The best way to learn. Fail fast, fail a lot, and you can go all the way to shell scripts and finding things. For example, this is something that I was lacking. But we went through all of this all the way here to creating a script. And for you, my friend, that was telling me about that, that what happened if we just add asterisk txt. Here is the trick. In this Nels pipeline creating script, you will find it. Okay. So everything is in there for you. It's free to use. It's free to get it, and you can find it. Okie dokie. All right. So are you hungry? Good. Go. Time to go to lunch. Yeah. The next one. Yeah. If you don't know, we have more trainings for you. We have the next thing that we have is the Conda. The Conda for data science, then the introduction to Python, which is also with me. And then after that, we will have the hands-on of AI tools or techniques. That's with my colleague, Abdul Raful Halimi. You will be using this platform, the Class Hub, for sure. Or if you do not have access to Class Hub, please set up the stuff on your own computer. So we will try to get you into Class Hub for those that didn't have access. So anyway, that's the thing. These three are actually prerequisites for these three here. Okay, many of the mumbo jumbo that I'm talking to you will be again put in place in this place. My colleague Abdul Rafur is very good explaining machine learning, so you're invited to come if you just want to check it out, right? Okay, so any more questions? No? Anything else that you want to know? No? All right. Thank you very much, everybody. What happened here? Bye.